is the cam kinematics. The cam kinematics. That means kinematic analysis of cam. Kinematic analysis of cam. The first topic. Second topic is cam synthesis. So all of you write down this one. I like to check your copy you have to submit. There you will learn kinematic synthesis of kinematic synthesis of cam. And after solving cam kinematics, there will be dynamics of cam or cam dynamics. So as you know, first solving the kinematic, then dynamics means cam kinetics. So cam kinetics is here I'm talking about the cam dynamics. But undergraduate course you have these two. Not undergraduate course, rather this theorem machine paper you have these two. That means cam kinematics and cam synthesis. So we'll cover these two, and cam dynamics will be in your higher classes. So cam dynamics will be covered. Now in kinematics or in kinematics, that thing is the follower movement, because cam is continuously rotation. Okay, so if it is rotary cam, if it is a translatory cam, it is translate. So important thing is the follower, because follower has to follow a desired motion characteristics to do certain work, or to serve certain purpose. For example, valve opening and closing in case of IC engine, this is the purpose, and there is a time sequence. So cam follower movement such that it should follow that time sequence, and the displacement of the cam should be such that it should do the intended purpose in the valve opening and closing. But cam will rotate continuously. Now, as I mentioned here, definition of lift you already know. Okay, that the greatest distance or largest distance that follower moves in case of a your linear follower, translatory followers. Okay. Now this graph shows that this is popularly known as displacement diagram. Along x-axis is your angle of cam rotation, say in degree or radian, whatever you like, and along y direction, linear displacement of the follower in case of a radial cam follower mechanism. So here we are talking about the radial cam follower mechanism only. Now this is the example of a radial cam follower mechanism, a disc type radial cam follower mechanism, where the follower will move in radial direction and cam is rotary disc type. And as you see very closely the displacement diagram, you just see there the different phases. For example, from here, when the cam is a cam starting point, let us that is the 0 degree. Now follower will climb over that. Follower will move upward direction. That means away from the cam center. So that is called the rise. How long it will rise? Up to this portion it will rise. So your symbol to use here theta Ri. Ri means theta subscript Ri. That I have taken this is from the Sigle's book, so they have used the beta one, but I like to use here theta Ri. Theta Ri means rise. So angle covered by the cam during the rise phase of the follower, that angle is theta ri. Then there are the certain portion where cam has no displacement, that is a dowel period. There also there is a angular movement of the cam. After that, cam return phase, passing through the return phase. That means, sorry, follower will passing through the return phase. What does it mean? That means follower will move towards the center of the cam. Just
Sir,
just a minute. Is it
Sir, will
visible?
you?
Is it
Yes, sir.
visible?
yes,
Yes,
sir.
sir. Sir,
Tell
will
me.
you tell us which one is theta RI?
Sir,
Theta
did you
Ri,
mark something
instead
with
of beta 1, you just think is a theta Ri. Instead of beta 1 here, you just think this is theta Ri, because I like to use this
okay,
symbol theta Ri. That means 0 to this. Okay, if I see here, here this one is theta Ri. Theta Ri. That means from 0 to theta Ri, that portion of the movement of the rotation of the cam, there is a rise of the follower. That means follower will move upward direction away from the center. Okay. After that, follower will have no displacement. Follower is stationary, but cam will move. Next is the cam will follower will passes through the return phase. That means from its lift position, that means the highest position, it will try to move in a downward direction. That means towards the center of the cam. Follower translate towards the center of the cam. That is called the return. And most of the that how it will return, how it will rise, that particular mathematical modeling we like to do now. So the definition wise, as you know, that your rise is the portion of the displacement diagram. So from here it's figure, it is clear, the portion of the displacement diagram in which motion of the follower is away from the cam center, that is moving away from the cam center, that is rise, and it will reach at a maximum height, say in case of a this type of follower, and that maximum height is known as a throw or stroke or the lift during after rise phase. Next will be dowel. Dowel is the portion of the cycle during which the follower is in rest condition. See, there is no displacement of the follower, but cam is continuing. Next is the return. It's the portion of the displacement diagram in which motion of the follower is towards the center of the cam. So towards the center of the cam that I have shown here, that is the downward movement in this case. So we already mentioned these are the different types of follower movement, rise, return, rise, but it is very limited use in the industry. Next is dowel, rise, return, and obviously again dowel will start. So these have more frequently used than previous. And the widely used one is the dowel, rise, dowel, return, dowel. Though it depends on your application, but the third one, so it's the dowel, then rise, then again dowel in between. But it may the time of the dowel or period of the dowel may be short. Then return, then again it is dowel start, then again rise, like this way. The follower will move, and that one we like to we like to analyze the third one, and second one and first one is the special case of the third one, when dowel you can control it, dowel you can eliminate it or minimize. So the follower motion that we like to cover now today is the uniform motion. That means the motion with the constant velocity, and its advantage and disadvantage, and what modification you want. Then the uniform acceleration and deceleration motion, which is also known as parabolic motion, then simple harmonic motion, and cycloidal motion. So all of you just write this one. Quickly write. The motion of the follower we like to consider here is the uniform motion or the motion of constant velocity and its modification. This is the first one we like to do. We like to analyze. Second one, we just write the uniform acceleration and deceleration motion, which is also known as parabolic motion. Third case we like to consider here the simple harmonic motion. Okay. Fourth one is the cycloidal motion. Today we like to discuss these four. Many more is there. And also you have to find out the advantage and disadvantage and applicability of this type of follower motion, because the most of the competitive exam you can find out that they will ask what are the applicability, which particular situation you will apply, which particular motion of the follower. So that is very important from the MCQ point of view. So now is under this heading of the uniform motion or the motion with a constant velocity. Now here, what do you mean by uniform motion or a motion with constant velocity, or uniform motion of what? Can anybody tell me that what do you mean by
The
uniform
follower,
motion or
of the
follower?
follower.
Because of the
The
follower,
uniform motion of follower.
uniform motion of the follower, which is also I'm talking about the motion of constant velocity. Now just see, during the rise, let us say this period is rise period. You forget about the dowel and the return. Okay, the dowel means no displacement. That means the motion, the velocity is zero. But when there is a rise, that means from this point to this point, this is the rise. So along this is your movement, the cam rotation theta is the cam rotation angle. You draw this one. Above that, you just keep some spaces above and below, because I have to draw a few more. So you just see here this portion is the rise portion of the cam. This is the rise portion of the cam. Here the rise. During this the time that you just see, this is y direction is your velocity, not the displacement. Here I'm talking about here the velocity. That means if your displacement is y, then velocity is y dot or v. Y dot or v, whatever symbol. Y dot means dy dt. So velocity, and that time in the rise page, velocity of the follower is constant. So that is why it is of constant velocity that I mentioned. If it is so, now what could be the displacement diagram? This is the velocity diagram with respect to cam rotation, or even cam rotation is basically it is your uniform cam rotation, constant velocity, that you can take that x direction is also the time and theta is the proportional here. So that is why there will be no problem at all, either with theta, or even it is same as that omega t. That means you can say the x axis is just like a t. Now the velocity is constant. What could be the displacement diagram? It's a class 11 level
Sir, the
physics.
linear. Sir,
Sir,
it will be
incline
linear.
Straight line passing
Sir,
through
it will be
regions.
It's a straight line. It is the incline.
trapezium type.
It is the straight line. Up only rise portion, it will be straight line. Clear? Up to the rise portion I'm talking about now. So it will be the straight line like this. Is it okay? This one?
Yes, sir.
Displacement diagram will be this. So your displacement diagram, that means this one is a y. Displacement is a y versus theta. This is called the displacement diagram. So the first diagram, this one is called the displacement diagram of the cam. This is called the displacement diagram of the follower. So displacement diagram of the follower. So please draw this one. And I have given an example of one cycle, one complete cycle. That means 360 degrees. See, here the end, this is 360 degree. That meaning is one complete rotation of the cam, which way follower will displaced, that is displacement diagram. Next will be the time derivative of the displacement diagram is the velocity, and the time derivative of velocity diagram will be the acceleration. Now what should be the acceleration? What could the shape of the acceleration diagram?
Sir, zero. Sir,
Zero.
acceleration
Zero
will
first.
zero.
That
It
is
will be
zero.
zero.
That means
So it is
along
zero.
x-axis.
Parallel to x.
Along parallel to x.
So along x-axis.
Along,
Along
along
x-axis.
x, not parallel, along x-axis. Rise period, you just tell me rise period. Forget about other period. Rise of the follow. That period, your acceleration, where it will be?
So infinite, sir.
Sir, it will be
So
along
on
Infinite.
x-axis. Along x-axis.
Along x-axis. But somebody mentioned infinite. Very good answer. Because you just see, in this case, you just mentioned when the time t equals to 0 says once or it has been some double period has been mentioned here, but still you just see instantaneously how the constant velocity v you can achieve. This is the y dot or the v say. So this is your v. So how you will reach the v velocity without acceleration? Is it possible?
No, sir.
Because your velocity is constant, that means dvdt should be equals to 0. So this priority is 0, acceleration is 0. But without acceleration, how will reach the instantaneously that your that velocity v? Is it possible?
no, sir.
No, sir.
So these are the things that I would like to explain afterward. But theoretically, you just see here that I mentioned that rise period is here up to is theta ri. So that I mentioned from the this is x-axis, the theta, y-axis is the forward displacement, and rise period. This is only rise period RISC. This is the rise period, and it is the angle covered by the cam is theta ri amount. So draw this picture, whatever I am talking, you just draw this picture, and now just see this is the the rise portion, displacement diagram of the rise portion I have drawn. Because if you can mathematically model the rise portion, other portion you can easily do it. It's basically now, as you know that uniform motion, what does it mean? It means the velocity of the follower is constant. That means dy dt equals to constant. That means slope of the displacement curve or displacement diagram is constant. Clear? What does it mean by the uniform motion? Uniform motion means velocity of the follower is constant. A velocity of the follower is constant that you have seen. That means dy dt. dy dt is constant. And that interpretation of that one is, physical interpretation is slope of the displacement curve. Slope of this one. Slope of this curve, this displacement curve is constant. This is the physical interpretation of this mathematical representation. Now, in the uniform motion, the displacement of the follower is proportional to the angle of cam rotation. From here, it will clear. That means it has a linear relationship that you have already identified. That means y equal to c theta. So this equation of the straight line is y equal to c theta. This equation straight line is y equal to c theta. Where c, you know that you can say here constant of proportionality. That means here the you can say if it is y equal to mx plus c kind of thing. Y it is a slope m. You know, straight line equation y equal to mx plus c, where intercept is 0, say. Let us say in this case no dial previously that I have shown intercept is 0, and equation of straight line you already know y equals to and is one way to equate y equal to mx plus c. Mx plus say c naught. Here intercept equal to 0, then y equal to mx. That here x is along x is theta, so y equal to c theta. C is the constant of proportionality, but physically it is the slope. What is theta? as your cam is rotating the omega constant RPM, that means theta equal to omega t, because you know omega, what will be the omega? Omega equal to theta by t. Omega equal to theta by t. That means theta equal to omega t. Omega is the angular velocity of the cam. Theta is the angle of cam rotation. As the constant angular velocity, that means theta will also uniform. So angle of cam rotation is uniform. So from here it is clear, along x direction you can treat t also, time. Instead of theta, you can put t, because it is omega t. Omega is constant. So that way you can treat this x-axis is same as the t. So y equals to cos theta. I think all of you have note down in your copy this one.
Sir,
Tell me.
sir, right now you said that there is no acceleration, but there is velocity. But I think there is angular acceleration. That's why this velocity is coming into role.
If your omega is constant, so your constant RP, then tell me how much will be the angular acceleration?
So in that way, angular acceleration will be zero. But if we go by v square by r,
First thing, at this one I am talking about this the follower motion, no? Displacement diagram is the follower, and omega is for the cam. Omega, there are the two things, no? One is the cam, another is the follower.
yes, sir.
So whatever I'm talking about omega, that is related to cam, and whatever I'm talking about y and y dot and y double dot is related to follower. Here omega alpha will be there, but alpha is 0 because omega is constant. Omega is not omega naught plus omega alpha t. Omega is
Okay.
constant. It is not the equation following any equation like omega equals to omega naught plus alpha t. Not following this equation in this case, because it is our assumption that omega is constant. If it is
Okay.
not, then there will come into the picture.